Thank you.
Okay, hi everyone, my name is Lydia.
I'm Caitlin. And I'm Michelle.
So our presentation is on tree line movement in Alaska. As you know, climate change affects all Earth's ecosystems. So more and more studies have shown that global temperature are rising, and it's no surprise. But current research by Gareth Rees et al. In 2012 has shown that the tree line is advancing, and it has potential to be advancing more than 100 meters a year in the northern forests. So we were interested to see how the forest tree line in Alaska, in particular in these areas here, responded to this temperature change and how it compares with the study by Gareth Rees. This is South Central Alaska, and our actual locations are Denali Highway, and Valdez. And these are locations that we took from Michelle. She spent last summer doing a project in Alaska, and she took three sample cores of the white spruce. So we had the locations, and we said, well, let's use the data that we have where we know the trees are actually there. So as for climate, these two areas are quite different. Denali here gets about 17 inches of rain a year and about 52 inches of snow on average. And Valdez gets considerably more, about 68 inches of rain and about 500 inches of snow a year, approximately. And also, as for the days are quite long. So in the summer, in July, the days are about 19 hours long, and the shortest days are in December, that are about 5 hours long.
Okay, so we wanted to validate the proposed change that we found in our research using remote sensing methods. So we started by downloading 1980s images for all of the sites using Landsat 4 and 5, and then present day images using Landsat 8. And we chose summer images because you could best see the vegetation change. And we also selected based on which years had the lowest cloud cover. So for two of the sites, they were the 1986 and 2014 images. And for the Valdez site, the lowest cloud cover was on the 87 and 2015 images. So after that, we made ROIs using NV in order to focus in on our exact locations, and then created NDVIs for each of the three sites, which you can see here. And the white represents areas of increased photosynthetic activity. And we also performed unsupervised classification so we could select which areas showed the vegetation cover, and then exported that into ArcGIS so that we can measure the actual change in meters between the old images and the new ones. And so we selected 10 random points using a random number generator for each of the three sites, and then using ArcGIS we measured the change between the old images and the new ones to create the averages for tree line change in each of the three sites.
So if we go back to that first set of images, which are our NDVI images, the top row represents the historic vegetation, and then the bottom row represents present day vegetation. So it's pretty clear across all three sites that there's been an increase in photosynthetic activity. But this kind of conflicted with the results we got from our classification. So this is our classification for the Valdez site. Here we've put the present day vegetation, so 2015, in light green over the 1987 vegetation, which is in dark green. And it's pretty clear that tree line is actually receding at this site. And when we averaged our points for this site, we got an average of about -8 meters per year. So that means that tree line was receding in that case. And this was true for about 2 of our 3 sites, which wasn't what we were expecting. We were expecting something more like this, which was our Denali site. Here is a little bit of the reverse. So we have our past tree line in dark green, which is overlaid over the present day tree line, which is in 2014 and is the lighter green. So here it's pretty clear that there's an advance in tree line. And on average for this site, tree line moved at about 26 meters per year. So when we averaged all together across all 3 sites, we got about 5 meters per year. And as you could guess, this was significantly different from the hypothesized tree line rate of about 100 meters per year that was proposed by Reese et al. In 2012. And we found that using a one sample t-test. Using a power analysis to see something of a similar tree line advance rate, we would have needed a sample size of like well over 100. So this is something that we'd propose for future study. If someone were to repeat this method, they might consider increasing their sample size by a lot. And then maybe increasing their sites to all over the state, although it was kind of hard to find images that were clear of cloud cover. Additionally, we would suggest possibly going more in depth into that classification to really like see where tree line was. That was kind of difficult for us. Ultimately, we did find a change in tree line. At all 3 sites, there was movement. There was this dynamic change that was basically related to climate change. And it's really important going to the future to understand these ecotones, these different boundaries, and the way they interact with climate change and the way that they will interact in the future. Thank you. Any questions?